Question 5, okay, we're going to prove this one again, and it gives us a restriction n is greater or equal to 1. So I'm going to do step 1, show it is true for n equals to 1. Again, this is our general term for the left-hand side, so I'm going to substitute n equals to 1 into there, just like this. Okay, so all the 1's go into the n. And simplify that, guys, you should get 1 on 3. Okay? Now the right-hand side, substitute n equals into there, n equals to 1 into here. So I have 1 here, and you should simplify that to 1 on 3. So you can see that the left-hand side equals to the right-hand side. Therefore, it is true for n equals to 1. Okay, very, very simple step. Again, very free marks you can get. Now let's go to step 2, which is assumption. Assume that it's true for n equals to k. So replace all your n's with k, just like that. Now step 3, and you can see our assumption over here. We'll use it in step 3. Now step 3, show it's true for n equals to k plus 1. So replace all your n's, or in this case all your k's, with k plus 1, just like this. So see how this one, that one is here, and we're going to add an extra number, extra term, because we're adding one extra term to n. It's going to be 1 over 2k plus 1, so basically I'm subbing in k plus 1 into here so I can find what the next number is. Here, if I sub in k plus 1, it's going to be like that, 2k plus 2 minus 1, which is 2k plus 1. This goes into there. Okay, and similarly, I just subbed in k plus 1 into here, so I have 2k plus 1 plus 1. So it's 2k plus 2 plus 1, which is 2k plus 3. This goes into here. Very simple. Okay, so that's all I did, guys. So there's no tricks that I've done. So have a good look at that one. I'll just rub this all off because it's easy and it's messy. And I'm going to sub it k plus 1 into here. So it's k plus 1 and k plus 1 into here. So I get 2k plus 3, and I won't show that again because I've showed it over here. That's how I get both of these left-hand side and right-hand side. And now let's start the proof. So I'm going to start with my left-hand side, which is all of this, which turns into this. Now to see why, you can see that this remains over here, so I left that alone. So you can see that I've changed this. I use a different color. You can see that from our assumption, all of this is this. They're exactly the same, aren't they? So I can replace this one with this, so it goes over here. That's how I got that. Okay, so have a good look at that. K over 2k plus 1, it goes over there, which it replaces this big thing. Alright, so have a look, and all I need to do is simplify it. So let's make it into a single fraction. You can see that the common denominator is going to be 2k plus 1, 2k plus 3. But we don't have the 2k plus 3 here, so I'm going to multiply both the top and bottom by k plus 3. So that's why I have k times 2k plus 3. Whoops, sorry, that was meant to be a 2. My bad. K times 2k plus 3 plus 1. And this side, they both have the common denominator of that. Okay, so that's how I made it into a single fraction. Simplify your numerator like this. All I did was expand and simplify it. That's what I get. And you can see I have a quadratic. Use your cross method to factorize that. We've done that so many times in our quadratics. So that's what I get. Make sure you get the same factorization as me. And have a look, guys. These are the same. So you can cancel. So we just have k plus 1 over 2k plus 3 left. Now you can compare it with our right-hand side. Is it the same? Yes, it is. It is our right-hand side. So therefore, I can say if the statement is true for n equals to k, which was our assumption, we can also say it's true for n equals to k plus 1. Therefore, it is true by the use of induction. Okay, so that's it, guys. Have a look.